Good afternoon, dear students. Today we are going to see the quantum mechanical model of atom. That is second unit in 11th standard, first volume book. Quantum mechanical model of atom. That is our second lesson, unit 2 in the first volume, 11th standard chemistry. That we are going to see now. Okay. So you know very well all the universe made up of matters, all the matters made up of atom. There is a long progress of the history of the atom. Okay, first Dalton's assumption that atoms are indivisible or non-divisible, that it cannot break. Like that, he assumed that. But it is wrong. After that, they found the subatomic particle. Then, J.J. Thomson model. J.J. Thomson model, it is using a cathode ray. Cathode ray experiment says atom is negatively charged particle. Okay. It is surrounded by the sphere of positive protons. He assumed that atom will be electrons like this in a circle. These are positively charged protons. Assumption. Inside that electrons are located. Like water. See, electrons are inside the atom, outside the positive layer will be there. This is a cathode ray experiment of J.J. Thomson. It's also proved to be wrong. Okay. Then Rutherford's atomic model. Rutherford's atomic model says that electrons are revolving around the nucleus. This experiment, there is a alpha ray experiment. Alpha ray experiment that we use. Rutherford atomic model, alpha ray experiment. What he is saying is, when you bombarding the alpha rays into the gold foil. Okay. See, this is an alpha ray experiment. What is a Rutherford alpha ray experiment is nothing but this is alpha ray. The alpha ray is bombarded to the gold foil. Okay, gold foil. What happened? Many of the alpha rays passes through the gold foil. Few of them slightly reflected. Okay, slightly deflected. Very few of them are directly reflected to 180 degree reflection is there. Among this observation, what are the three observations he found that many of the rays passes through the gold foil. Okay, some of the rays are deflected slightly deflected towards that. Okay, then very few rays are reflected 180 degree. Okay, by assuming this assumption, he come to the conclusion that there is a nucleus, there is a positive charge, there is a proton in the nucleus is there. Proton present in the nucleus where electrons are revolving around the nucleus. This is the assumptions of Rutherford. But if you assuming that when a body randomly or high speed revolving around the nucleus, this is the nucleus here. If you take this, electrons, if you revolve around, and finally it fall down. The energy on body is continuously revolving around, then it loses some energy. While you, because of the losing the energy, it will be fell down, it is delocalized, that will be destabilized. But what happened? Atom is a stable one, okay? But it proved to be wrong. For example, if I say I am asking to come round the round. At first time with the full energy you are rounding in a proper circle way. After sometimes you lose energy, what you tend to do, if you ask to round like this, then little bit energy is losing, at last you will fall down. Likewise, if according to Rutherford, electron revolve around in a continuous speed, continuously, there will be a loss of energy. If the electron will lose the energy, may fall down. It is collide with the nucleus. It come down to the nucleus. If the electron is there, it is round. At last it come to the nucleus. There will collapse take place. Because of the collapse, the atom will be not stable enough. But actually, in practical, atoms is stable one. So this method also proved to be wrong. So far we have seen that three: Dalton's, J.J. Thomson, and Rutherford. And then we are going to move on the Bohr's model. Okay. Bohr's model. Bohr says that he is giving some assumption. Okay, Bohr's postulation. What is the best? Energies are quantized. Energies are quantized. Energies are quantized. Okay. The energies are fixed. This is a drawback of the Rutherford model. There is no fixation of energy, a particular level. What is the level of the energy level? What is the energy of electron is not fixed in a Bohr's Rutherford model. It is fixed. Energies are fixed for certain level. For example, first level, energy level 1, energy level 2, energy level 3, energy level 4, like this is assuming this. So this circle, this first way, it will have a N1 will have a certain amount of energy, fixed amount of energy. N3 will have a fixed amount of energy. N4 will have a fixed amount of energy. So energies are quantized, fixed. Then second concept is orbit. Electrons are revolving around the nucleus in a certain fixed path. Electrons are revolving around the nucleus in a certain fixed path, not randomly. In a Rutherford says that it is move around randomly in a high speed. That is not there. Here it is fixed path. Electrons are revolving around the nucleus in a fixed circular path. That is called orbit. That is path is called a orbit. That is called a orbit. Then the revolving around the angular momentum mv are equal to nh by 2 by. Angular momentum mv that is equal to nh by 2 by. That is equal to the angular momentum that is equal to the nh by 2 by. H is a Planck's constant because Bohr's model based on the Einstein-Planck's model only. So this is then fourth one. Okay, when if electrons are revolving in a fixed path, there is no loss of electron. That is his concept. In a Rutherford model, if an electron revolves randomly, there it loses some energies. But here it is revolving around the nucleus in a fixed path, so there is no loss of energy. Then he is saying that whenever if there is a electron may jump from one energy level to another, this level to that level, higher energy level to lower energy, because this may be fourth level electron may jump to the third level. Okay, a electron may jump to the third level. So there will be energy loss. This energy loss is equalized by electromagnetic radiation. Okay, if some amount of energy is there, when it loses some energy as electromagnetic radiation, then it is come here to the third level. Likewise, it can jump from higher level to lower level. Then the same way, it can, if you supply some energy, if I am supplying the energy to the second level, extra additional energy is given to the, it can jump to the third level or fourth level. So, electron jumping may possible from higher level to lower level, lower to higher level. So then, it may be given the energy of the electron E2 minus E1. Okay, that is equal to h nu. Nu is the frequency. Then you want a frequency E2 by E1, then h. Then you will get frequency that. H is a Planck's constant. H is Planck's constant. That is equal to 6.626 into 10 power minus 34. Okay, joule second. This is the H value, Planck's constant value. These are the assumptions. Based on this assumption, he is come to the conclusion that the energy and the radius of the electron, in the radius of the electron in the nth orbit, radius of the electron in the nth orbit is given by 5295 z n square. Okay, Armstrong. The radius of the electron is given. Radius of the electron is given this value. Then energy of the electron in nth level. Energy of the electron in nth level. Energy of the electron in nth level is given to that. Minus 13.6 z square by n square. Electron volt per atom. Electron volt per atom. Okay. Likewise, energy of the electron in nth level, it can be given by minus 1312 z square by n square kilo joule thermo. Okay, the radius of the electron can be given like this. The energy of the nth electron, if n may be 1 mean, you can substitute 1. If n equal to 2, in the electron volt per atom, the minus is a indicate the negative sign. This is a negative sign, indicates that the loss of energy. Then En come like this. These are the factors or assumption. Based on the assumption, we can give a radius and the energy of the electron in the atom. Now let us move on to the limitations of Bohr's model. What are limitations? First limitation for the Bohr's model is it is only applicable for one electron pieces or one electron-like pieces. For example, hydrogen it is applicable, okay. Then helium plus also one electronic pieces, okay. Then lithium 2 plus. So it is only applicable for the one electron pieces only. So it is not applicable for other pieces other than the one electron pieces. So there is some limitation for this. Then second things, splitting or spectral line. Splitting or spectral line is not, it is unable to explain. It is unable to explain the splitting or spectral line in a magnetic field. That is nothing but a Zeeman effect. Zeeman's effect. Then in an electrical field. There is nothing but a Stark effect. So these both effects are not well explained. It is unable to, Bohr's model unable to explain the splitting of spectral line in a magnetic field and electrical field. Magnetic field is nothing but a Zeeman effect. That is Stark effect. These two is not well explained in a Bohr's theory. Then final assumption, if you take the limitations of the Bohr's model, is nothing but that is not well explained. It is not properly explained about the fixed path, how electron revolving around in the nucleus in a fixed way. That is not explained. Then there is no evidence for the angular momentum that is equal to n is 2 by. This is given theoretically only. This explanation is not clear enough to explain in this. These are the limitations of Bohr's model. So once again I am repeating what are the limitations of Bohr's model. It is applicable only for one electron pieces like hydrogen, helium plus or lithium plus, like the lithium 2 plus. And for other electronic pieces it is not applicable. Then splitting a spectral line of magnetic field as well as electric field, both are not explained. It is unable to explain this splitting of spectral line. Then there is no evidence or proper guidance to that MVR equal to mh by 2 by, and also there is no explanation regarding that fixed pathway, how electron energies are fixed in a certain pathway n1, n2, n3, how the energies are quantized. There we are saying that energies are quantized in orbit, that there is no explanation for that quantization of the energy, and it is equal to the nh by 2 by that value. It is not explained in a Bohr's model. These are the limitations of Bohr's model. Then let us move on to the duality of the electron. So let us move on to the duality of nature. Duality. What is called duality first of all? One has two natures. That is called duality. On those days, Albert Einstein discovered that light has a dual character. What are the dual character? Wave character and the particle nature. Both wave and particle nature. Light, for light only he is giving assumption that light has a dual nature. Light photon, it behaves both wave and particle. What are the properties of wave and particle? If you see, there is two are very different. Wave is a local, wave and particle is a localized one, wave is the delocalized. But particle do not interfere, whereas a wave they can interfere. These are the difference between the wave and particle. But light photon behaving both in a simultaneously, both it can behave as a particle and it can behave as a wave. That is given by Einstein for light. After this assumption, Deepbromley getting the result, all the matters can have a duality. All the matters can have a dual nature. For small to bigger, that electron, proton, everything will have a duality, dual character. They all of them having the both wave nature and a particle nature. That is given by Deepbromley. Then let us move on to the Deepbromley equation. Deepbromley equation. So this equation mostly based on that electron has a dual character. This is a main theme of the Deepbromley wave equation. It is assuming that there is a electron has a both wave nature and a particle nature. Okay. Where is the sources he getting from that? Planck's equation. From Planck's equation, if you assume that wave, electron is a wave, then energy from the Planck's equation h nu, where E equal to energy, h equal to Planck's constant, nu is a frequency. Okay. If it is assumed to be a particle, Einstein coming. Einstein giving that E equal to mc square. Okay. Planck's equation, energy can be given for the wave, h equal to h nu, whereas Einstein can give a energy that is equal to E equal to mc square. Deepbromley comparing, this may be equation 1, this is maybe equation 2, is comparing these two, then h nu equal to mc square. We know very well that nu frequency equal to c by lambda. This is we know very well already. Okay. Then you substitute this in here by comparing 1 and 2. 1 and 2 we are getting this one. This is 3. You substitute the new value in the 3. That is h c by lambda. That is equal to mc square. Okay. Then c cancelled, square cancelled. Then lambda equal to h by mc. This is a Deepbromley equation. lambda equal to h by mc. Here h is a Planck's constant, c is a velocity of light. Okay. If it is, that is, or otherwise the various form of the de Broglie equation, lambda equal to h by p, that is nothing but the product of mass and velocity, that is equal to momentum p, lambda equal to h by p. If you assume that there is a particle, then you can write lambda equal to h by mv, h by mv, h by mv. This is velocity. Okay, the velocity of the particle, c is the velocity of light, h by mv. These are the various form of the de Broglie equation. What is the de Broglie equation? De Broglie equation is nothing but it deals about the duality of electron. What is called duality? The electron has possess both particle and wave nature. Where is getting the sources for the de Broglie equation? From Planck. Planck saying that it may be assumed that the electron may be a wave nature, then the energy equal to h nu. Okay. Here h energy E equal to energy, h is that Planck's constant, then nu is a frequency. If Einstein giving that equation that you are getting E equal to mc square, comparing 1 and 2, h nu equal to mc square. Okay, then we know that frequency nu equal to c by lambda. If you substitute the c by lambda here, h c by lambda equal to mc squared, c can c square cancel, then lambda equal to h by mc. Here m equal to mass of the particle, c is the velocity of light, h. Likewise, you can do that. H by p is nothing but a momentum. That is the product of mass and velocity, momentum p, or otherwise lambda equal to h by mv. Here v equal to velocity of the particle. Okay, this is a de Broglie equation. Okay, then what are the significant? It is only significant for microscopic particle. De Broglie wavelength wave equation only applicable or significant to the microscopic particle. That I can explain how it is only applicable for the microscopic particle. For example, if you take a iron ball, okay, iron ball is such a big one, okay, it's a macroscopic particle. At the weight of the iron ball, mass equal to 6.626 kilogram. Just I am assuming it. Okay, maybe 6.5 kg like this. Okay, then m value like this. Then if you substitute the value, velocity maybe 10. Okay, 10 meter per second velocity value. If you substitute the for a iron ball, you are substituting lambda equal to h by mv, where h equal to Planck's constant 6.626 in 10 power minus 34 divided by 6.626 into 10. Totally lambda equal to, it's come around 35 meter. Okay. It is impossible to get that. It is too small. Okay. So it is not applicable for the iron ball. That is not a macroscopic particle. So such a big particles, de Broglie wavelength is not applicable. For example, if you take electron, the same case. For electron, if we take, this is for electron. You know that mass of the electron m equal to 9.1 into 10 power minus 31 kilogram. Okay, that is a mass of the electron. Velocity, that is equal to 72.73 meter per second. If we substitute the same value, lambda equal to Planck's constant is 626 into 10 power minus 34 divided by 9.1 into 10 power minus 31 into velocity 32.72, this value. It is simplify these values, you are getting that 10 power 5. Okay, it is a measurable quantity, we can assume. So what the de Broglie is saying that de Broglie equation only significant for the electron-like microscopic particle. Electron-like microscopic particle. It is not significant or it is not applicable to that macroscopic particle like iron ball or any macroscopic particle. This is all about the de Broglie equation. So far we have discussed duality of the electron. Duality is nothing but both natures, wave and particle natures. So based on this de Broglie giving a equation, wavelength equation, that is de Broglie wavelength equation, that is getting sources from Planck and Einstein, then is substituting that he getting a de Broglie equation, wavelength equation, lambda equal to h by mc or lambda equal to h by p or lambda equal to h by mv. This is only significant for the microscopic particle like electron, proton, very small particles, subatomic particle only it is applicable. It is not applicable to that of the macroscopic particle. So today, in the introduction of the quantum mechanical model of atom, we have discussed the history of the atomic models. Dalton's, J.J. Thomson, Rutherford, Bohr, like these models we have discussed. Then what are the postulates and limitations of the Bohr's model we have discussed. Then the energy of the electron in an orbit, that formula we have learned, and the radius of the electron in an orbit, radius of that orbit that we have learned. Then finally we are limitation of Bohr's model and duality of the electron. Duality of the electron we have discussed. So remaining part we can discuss tomorrow. Thank you.